All right, guys, we're going to do the next couple tabs in our RC flipbook. So we ended with talking about using our stat to come up with the equation. I wanted you to finish example 3. To recap what you needed to do if you did not do this, X, remember, is your L1 and Y is your L2, okay? So you're going to have to go, let me just get my calculator up, just hold on. You're going to have to go to stat first. Okay, so we have to hit the stop button, we hit enter, and then you can clear out, remember, by going up, highlight it the list, and then hit clear, and then come down. I'm gonna go over, go up, highlight the list, and then hit clear and come down. So in list one, we're putting the hours, miles per hour. So we have 22, enter, 35, enter, 42, enter, 46, and 51, 62, and 73. Then we're going to arrow to the right and get the less 2. We got 17.2, enter. 23.4, enter. So some of you already know how to do this. And so you're just going to continue with the steps. Enter each data point, 29.5, and then 26.9, and 23. Yeah, you can do 0.0, but just 23 is the same thing, okay? Now, some things you need to make sure you do is see what the points look like on the graph. To do that, we have to hit second y equals, go to stat plot, which is enter, and we have to turn it on. And then if we go to graph, okay, so I have my old equation in here, so I need to turn that one off, clear, go back to graph. Now, if I don't see the points, this is when you have to hit zoom and pick number 9, stat, so we can see there. It looks like, almost looks like a parabola. Okay, it's going up, there's a turning point, it comes down. So they want us to write an equation. Part A says write an equation, quadratic function that provides a reasonable fit, round to the nearest 1,000. So this is when we're going to come up with a quadratic regression that goes to that. So now we hit stat, go arrow to the right, calculate, quad regression number 5. We enter 5 times. And so they want us to round to the nearest thousands. Thousands is 3 zeros, so we look at 3 digits and we round up. Or we look at the third digit and round up. If it's 5 or more, the number soars, goes up. If it's 4 and less, it stays, it rests, okay? So this is, the A here is a negative 0.13. And then our B, okay, 3 digits, this is gonna be our 1.35. And then our C, 3 digits, is a negative 6.823. Okay, so we're going to write that equation in here in standard form. So it's going to be y equals a negative 0.135 x squared, then plus 1, make sure it was positive. Let me go back to my calculator. Yeah, my B was positive. Okay, sorry. 1.355x, and then minus 6.823. Okay, just predict the number of miles per gallon for a vehicle driving 80 miles. So that's our x. So we're going to put this equation in the calculator and then predict. So we go to y equals, we're typing in our equation, a negative 0.135 x squared plus 1.355x, and then minus 6.823. We hit graph. Did I store it? Did. Zoom. We're going to go zoom fit, which is 0. I must have typed something wrong. Let me go back to my calculate quadratic. .135. Right, we're gonna have to pause. I forgot the 0, sorry. Plus 1.35x minus 6.823. Let's graph it. Back to 9, sorry. There it goes. Okay, so here we go. So now they want us to predict after 80 miles. So what we're going to do is go to our table, do second graph. Now 80 miles, that's a big number. Okay, we get x needs to be 80. So what you can do is go second window table step start, excuse me, and we want it to start at, let's just say 80. Okay, and now we're going to enter that in. We're going to go back to our table, and there it is. So our prediction is 15.177. Now you want to predict the maximum speed. Okay, so that if it's the maximum speed, because we look at our graph, it does have a max, so we just need to find that max, and that's what we're doing. Second trace through 4. That's left bound. Let's go right bound. We'll slope too far. Enter, and the max is about, we look at the y value, 27.177. All right, so make sure you get that done, and then we're going to go to the next tab. All right, so we're looking at domain and range and key attributes. Okay, we're going to talk about the comparison of the two. One is the equation. This is what we just kind of went over in the last part of the unit. So to find these attributes, you need to look at the graph. So we're going to go back to y equals. We're going to clear this out, and I'm going to turn off my stat plot. And we're going to type in the equation that they want us to compare, or write down the attributes for us. So we got x squared plus 2x minus 3. And we're going to graph that. Now, right now, we can't see that. And if you don't see the graph, you should always start with a standard. So that's zoom 6. And there's our graph, okay? So what they want us to find are the parts. The vertex is your max or minimum, okay? So we start off with second trace. We have a minimum. We need to go left bound, enter, right bound, enter, enter again. Our minimum is a -1, -4, okay? This helps us with our other parts in our box here. So this is the point right here, -1, -4. This had a minimum value. The minimum value is the y value. Like if I look at my graph, it's asking how low does it go? It goes right here at -4. So this equals a -4. Axis symmetry is the vertical line, and we still have some missing that understanding. It's the line of reflection. It's the line cuts in half. That's the x value, so this has to be x equals -1. Now our y-intercept, if we can't see it on the graph, I can calculate it because it has to be touching the y-axis, and for that to happen, the x value has to be 0. So I can go second trace, calculate the value when x is 0. Yes, it's at a -3. Okay, so this is the point 0, -3. Then our x-intercepts, roots, or zeros, that's where it touches the x-intercept. So I can't physically see it, but I can see it right here. This happens at a -3 and at +1. So we write x equals a -3. And I'm just going to put both positive, oh sorry, I wrote -1, sorry. X equals -3 and a +1. Okay. Our domain is always our real numbers, but our range correlates with our minimum value. Our minimum values. It is pointing up, then it's going to be every value of y starting at a -4 going up. So y is greater than or equal to -4. Now on this, they gave us a graph that we can physically see the vertex at that maximum value, and that is the coordinate at 2, 5. So 2, 5. The highest value is at 5. The axis symmetry goes through the x, that point, so it's x equals 2. Our y-intercept, even though it's open, it is at 0, 1. Our x-intercepts, there's only one x-intercept here. Only touches the x-axis, 1, and it's closed. So it's x equals 4. And our domain is not going to be all real numbers because we have open circles here. If it was an arrow, it would keep going down. Okay, so remember our domain is our x values. So I look down, it's open at 0. So this would be starting, and we go least to greatest. So 0 is less than x because it's open, we don't have equal to. And the next x value is 4 and it's closed. So it's less than or equal to 4. So you go basically left to right. When you do your domain, you scan the x-axis left to right. Range, we go low to high. So the lowest value is at on the y-axis right here. Even though it touches here at 4 on the x-axis, we'll look at the y. It's at 0, and the highest is at 5. So it's 0 is less than or equal to y, which is less than or equal to 5. Okay, so this one was slightly different because it had the open and close points, which you had to remind you of. Now we're going to apply that with some models. Okay, the height of the soccer ball is kicked in the air, modeling this equation. So we're going to use this equation to answer the questions, and they gave us a model here on the right. Okay, so this equation models or corresponds with the graph. So if I'm looking at the x-intercepts, okay, remember what touches the x-axis, they want us to interpret what that means in the model. Well, at 0, that is the starting point. When x equals 0, that's the start of the kick, okay? And when x equals 3, that's the end of the ball landing. All right. Pause. So now they want you to interpret the y-intercept and the max value. So y-intercept, again, this is the start. Sorry. Because it's right here. And our max value, that's the highest it gets. So that represents the highest the ball launches, the highest ball. And that max value looks like at 35. Our axis of symmetry, we can still get that. That's x equals 1.5. And our vertex would be 1.5 comma 35. All right, so we're going to ask you to practice some interpretations on our worksheet today. So make sure you do that. Thank you. All right, we're going to now use this real world scenario from our flip book to now kind of do some projectile motion problems, okay? This is an equation to show the flight path of an object in the air. And so what you're going to have to do on each scenario is use the given equation. So in this scenario, a soccer ball is being kicked, kind of like scenario in our flip book. It says 90 feet per second. Here's our equation. So we're going to use this equation as our y equals, okay, in the calculator, giving us the height in t seconds. So first start off going to your y equals and type in the equation. There it is, okay, negative 16x squared plus 90x. You don't really need the y equals 0. You can just so you can highlight your x-axis. You're going to graph it. And what we have to see in the equation is the full flight. We have to get up to the height, to the vertex, the max. And to help you see that or get the graph, the window to show that, you need to look at your table. So if I go to second graph, our table is starting at 80 because that was our last thing. So we need to change it to start at 0. So hit second window, table set at 0, and now go second graph for table. And what you want to do is look at these y values and look how big they get. The biggest it gets is like around 126. So that tells me my y value in my window needs to be a little bit larger than that. So if you go to your window and we come down to our y max, I'm going to make it 150. Okay, and now I'm going to hit graph. Now I can see the flight of the ball. And now I can start answering some questions. So you're going to use your table to help you problem solve. So one of the questions they ask us to find is the maximum height. So I can now go second trace. We're going to find that max, which is 4. We now have to move left bound, enter, and then right bound. Oops, that's a little too far. I'm going to go right there, enter, enter. So our maximum height of the ball is approximately right there, 126.56. So that's our answer here, 126.56. And this is how many seconds does it take the ball to reach the ground? Well, to reach the ground means when it gets to the ground, our time is 0. So if I look at my graph, I'm trying to find this intersection. So I'm going to do second calc 5 intersection. But I'm going to put this cursor over here because this is showing the ball going down. It's about right there. And then hit enter 3 times. 1, 2, 3. And it takes about 5.625 seconds. Okay. And so that's our answer for this one. Second, sorry, my pen stopped working. Seconds. So you're going to use the equations here to help you problem solve and find your max and find the point where it hits the ground. Now on the back here, one of the questions, I want to talk about this one, is same, we got our equation, but it says how long would it take the penny to strike a 6-foot person, okay? So that means we want to find the time, basically we want to find when the equation equals 6. So we're finding this negative 16 t squared plus 1250, and we want it equals 6. Remember, this needs to equal 0 to solve it, so we're going to subtract 6 on both sides, and now we have our new equation to answer. 1612 minus 1244. Now it equals 0, and now we can find that intersection. Remember, work on your window to do that. So I want you to finish this, and we're going to go over and check it in class tomorrow. Thanks.